IT office and the issue has been resolved, you get back to me, okay? Let's not make it too complicated. I think it's straightforward. When you submit your assignment, it will be marked, okay? So when I mark and you are not seeing your score, then two things. Either you did not submit or you submitted late, okay? And in any of those cases, you don't come to me. If you couldn't submit, go to IT office. If you submitted late, don't come to me. My rules are straightforward. Okay, so let's not make things very difficult. Okay, this whole week and last week, I've been working on some document, and I'm sure you've gone through your notes from last week. That's kinematics in 2-dimension, how to resolve a vector, and then we ended off on that's force diagrams. Okay, how to resolve. Now we left, I think, 4 or 5 pages of your previous notes. So I'll touch briefly on them and then we'll proceed with today's content. So I'm going to touch briefly on those 5 remaining slides on lecture 5, and then we'll continue with today's class. Now, from the previous class, we looked at force diagrams, okay, and then how to apply the Newton's second law of motion, okay, in finding the force and the acceleration on various systems. And if I should remind you of the Newton's second law, we said the net force acting on a system causes what? Acceleration. So we said that F is directly proportional to what? The acceleration of the system, which means we can rewrite this as what? Summation F, is equals to what? Ma, introducing the constant of proportionality, which is what? Mass. In other words, too, we can also say that F minus what? Ma, is equals to what? 0, good. Then under conditions of equilibrium, your acceleration here is going to be equal to 0, because once there's equilibrium, then that means that the net forces cancel out. So there is no acceleration of the system. Okay, so once the A is equal to 0, then we are going to get the equation sum of F is equal to what? Is equal to 0. And like we said, in resolving forces or finding the net force or net acceleration of the system, in 2-dimension, we'll be looking at the summation of Fx, equals to 0, and also the summation of what? Fy equals to what? Equals to 0. These are the main points we made mention of from the previous class. Now, so today we're going to make use of these ideas, and quickly we have a simple pulley system on our screen which we want to examine. Now anytime we are giving systems like simple pulleys, what we do is you have to first consider the forces on one side of the region. So you can look at it like this. So we split it into 2 halves. Now when we come to this left hand here, now the condition here is M2 is greater than what? M1. So just imagine having a rope tying 2 masses, where one mass is bigger than the other, hanging around a pulley. Automatically this mass is heavier, so it's going to drag the whole system down. On the right hand, it will be coming down like this, whilst on the left hand, it will be going where? Up, so it's like that, right? That is how the whole system looks like. So on the right side, acceleration of the system is down, but on the left side, acceleration is where? Is up. Then again, when you look at the system, because there's a mass here, there will obviously be the weight W2. okay, which is m2, okay, times acceleration due to gravity. And we, because there is another mass here too, we have m1, or let me put it w1, okay, which is m1 g, okay. Then of course, once we have a rope, okay, hanging the weight, then it means that we're going to have tension, okay, which will go opposite the direction of the weight. The same way we'll have tension here, okay. So we have tension here and we have what? Tension at this point, okay. And because it's the same rope, we are dealing with the same tension, okay. It's the same rope, so it's the same tension within the system. Okay, very well. So what's next? Then what we do is, because we have a left hand, okay, forces on the left hand, or vectors on the left hand, which are the weight, tension, and then acceleration. And also here we have tension, weight, and acceleration. Then we draw the force diagram for the two halves. The first diagram is here. Okay, we have tension up. This is the tension. Okay, this tension here. And then m1g down. Okay. Then you can also indicate acceleration what? Up, that way. Okay, so A is going up. Then, okay, so let me divide this portion before we continue. So let me divide this portion. So this right hand is for the force diagram. Then when it comes to the right hand side of the system, we have tension up, you have m2g down, and then you also have acceleration down, okay? So if we are writing this in terms of applying the Newton's second law of motion, then for this system, we are going to have the forces there will be what? You see, because t is going up, it will be positive, okay? m1g is going down, so that will be negative, right? And then acceleration will also be what? Positive, okay? So let's write the equation for that system. That is going to be t, okay, minus what? m1g is equals to what? Is equals to m1 what? A, okay? Now, the question is A positive or negative? It's going up, so it's going to be what? Positive, okay? So we take note of that. And somebody will ask, why this equation? We said that the net force is acting on the system, okay, is always equals to the mass times the acceleration of the system, okay? So these are the forces that are acting on the system: tension and what? And weight. So when we sum tension and weight, it should be equal to the mass at that side times the acceleration of the system, okay? And the mass here is m1, and the acceleration here is a, which is positive. So that gives us equation what? Equation 1, okay? That will give us equation 1. Let me change that and make it black. So that will be equation what? Equation 1 here. Then let's go to the next equation. To the right hand, let me put it that way. Okay, so on the right hand, we have the forces here, our tension, okay, then we have m2g, and then we have acceleration downwards. So we can write tension, okay, minus tension minus what? m2g is equals to what? Is equals to minus m2a. Minus because your acceleration is downward, which is negative, okay? This is negative, this is what? Positive, okay? So you take note of that. So that gives us the second equation. So which means that we can make any of the tensions, or we can even subtract equation 2 from equation 1. This is equation 2, okay? So by substitution, we can make or by, elimination. Let's use elimination. So that will be what? Equation 1 minus what? Equation what? 2. Okay, so I'm going to do elimination to eliminate T and then obtain my acceleration of the system. So that will give me M1 minus M1G, okay, plus M2G is equals to what? M1, M1A, okay, plus what? I need more space there. So let me clean that section. Okay. So I'm rewriting again. That will be, so minus M1G, okay, plus M2G, okay, is equals to M1A plus what? Plus M2A, okay, good. So looking at it, we can find our acceleration of the system by factorizing A out here, and equally we can also factorize G, which is common on the right side. And on this side too, we can rewrite these terms. That could be M2, okay, minus M1G, okay. Then we factorize G out, okay, is equals to M1 plus M2A, okay, M2A, good. So that is how you do it. If you want your acceleration, then we divide both sides by what? M1 plus what? M2, okay, right? Then you divide this side too by what? M1 plus M2, okay. Yeah, once you do this, okay, this cancels out that, and then you are left with acceleration equals to what? M2 minus M1, okay, times G over M2 plus M1, okay. So that is how you get acceleration. If you want the tension, you go and substitute your acceleration in here, okay. Yeah, so you are going to do that, okay, substitution. So that will be M1G is equals to M1 what? Then you put your A in there, which is what? M2 minus M1G, okay? So for the lack of space, M1G over what? We have M2 plus what? Plus M1. Okay, so you take note of this. And then once you simplify, you will come to this equation, which is T is equals to 2M1 M2 over M1 plus M2 chain. Okay, so let's go on to the next proof. I'm going to clear my screen. Yeah, on the next proof, we have this system here. Okay, we have one block on a frictionless surface, okay, horizontal surface, and the other one being hung by means of a rope. So we apply the same principles like we said. You split the system into two halves, okay. Here we have tension going up, that will be T, okay, and the same T will be in this side of the, okay. Then we have the weight of the object also acting here, okay, that will be W2, which is M2, okay, M2 what? M2G. Of course, once we have weight here, we have the force M1G, which is weight of M1. Then you have the normal reaction force R, okay, or N, okay, good. So when we bring it, now again, we have to indicate the direction of acceleration, okay, because M2 for this system is bigger than what? M1, and the surface is what? Frictionless, okay. Acceleration of the body is going to be what? Downward. Okay. So once again, let me change color here. So acceleration will be what? Negative. Tension will be what? Positive. Weight will be what? Negative. When it comes here, this is going to be the acceleration is going this way, right? So once we are going the positive x, acceleration will be what? Positive, okay? And then tension will be positive, okay? Good. So you take note. Then let's take the next step. So in the next step, once we've transferred this here, these are the force diagrams, okay? And like we said, we have on the right side, acceleration is down. On the left side, we have acceleration going forward. So this is plus, this is negative, this is plus, this is plus, this plus, and then this is negative, okay? This is negative. Then again, yeah, so again in this system here, because the motion of this object, okay, is moving, the body will be moving, okay, forward like that, okay? It's moving in the horizontal direction, okay? It's not going up, or neither is it coming down, which means that your reaction and then your weight, okay, balance out. But in any case, because the motion is in the what? Is in the x direction, horizontal component, okay? The only force that is causing this body to move is the tensional force here. There's only one vector that is dragging the body, okay, along in the horizontal, and that force is the tension force, okay? So while this object drops to the ground, the tension generated in the string pulls it along on the horizontal surface. Like I said, the surface is what? Frictionless, okay? The surface is frictionless. Okay, so frictional force is equal to 0 over there. Or coefficient of friction is 0. That is what we are assuming here. Okay. Yeah, so moving on, we can write our equations. Let's take the right hand first. So for the right hand side, we have tension minus M2G is equals to what? The whole system is accelerating down. So it will be negative what? M2A for your first equation. Then for the second equation, like we said, the only force that is causing the acceleration of the system is what? The tension. So the tension is the only force, is the net force. This force here, N and then M1, the weights, okay, they are in the vertical what? Direction. So the only force in the horizontal direction, which is causing the horizontal movement, is the tension. So we have the equation tension is equals to what? M1 times the acceleration, which is A. And the acceleration is positive because we are moving to the right hand. Okay, so based on this equation, we can easily, because tension is equals to M1A in equation what? In equation 2, we can substitute it into equation 1. That will give us M1, just a minute. So that should give us M1, okay, A minus M2G is equals to what? Negative M2 what? A. Okay, so once again, we can easily factorize. Let me erase this side. Okay, so we can factorize on the right. No, we make A the subject. So that will be what? M1A plus what? Plus M2A is equals to what? M2 G. Okay, good. Yeah. So having done that, then we can factorize A now. Okay, and then make it the subset that will be M2G over what? Over M1 plus what? Plus M2. Okay, so that will give us what? The acceleration of our system. Okay, then once again, we said your tension was what? M1 times what? Times A. Okay, so you can just substitute this. The equation 2 we wrote earlier was what? Tension is equals to what? M1A. Okay, so we can do the substitution. Do that, and then let's see the outcome. So substitute and let's see the outcome. Yeah, I'm sure when you did your substitution, you had, okay, this equation here, which is T is equals to M1 times M2 over M1 plus M2 all times what? G. Okay, so that is for the next proof. Now let's move on to the third proof. Yeah, so in this third proof here, yeah, so for this third proof here, I gave you an oversight last week that once the plane is inclined, okay, you also incline your cardinal points to cater for the horizontal, for the inclined surface as the horizontal, okay. But it's the same analysis. So in this case, our plane, which was initially the surface was like this in the previous proof, which means that your x and your y, so this is horizontal. Now that the plane has moved, if the plane comes this way, like we are now seeing, okay, then it means that your horizontal too is going to, cardinal is going to go like that. And this will still be your x, whilst this is your y, okay? So it's the same, okay, the same concept we are making use of. So moving on, this is going to give us what? So let's indicate that here. I think it's even indicated by you. Let me just write it. So this is your positive x, okay? This is your positive y, okay, and of course negative x and negative y. Okay, now moving on. If you look at this object, this mass here, okay, the weight of the mass will always come down, as we are aware. So that will be W1, okay, and then the normal reaction, okay, will always act, okay, 90 degrees to the surface. So you have your R or your N, okay, at 90 degrees, right? Then of course, you have that component of the weight, which is what? Equal to your weight, that is apparent weight, okay? Then we can resolve the weight, okay, based on the 90 degrees here, which means that this angle here will be our what? Our theta, okay? So we have the angle theta here, okay? This is theta, okay? And then when we study carefully, because this is the adjacent side, because this is our adjacent side, we have W1, okay, cos of what? Cos of theta, okay? This W1 cos of theta. Whereas, so this is coming down, and then this side is going forward. So this will be what? Let me draw it well. So this one is that way. This is W1 sine theta because it's the opposite side, okay? That's the vertical. So Once it's moving, you see, this is a plane. So once it's moving this way, then that is what minus W1 sine what? Sine theta. Okay. So moving on, we've resolved the vector. One is coming down, one is going to the left. Okay, then here also we have the tension. So we have tension up here, T, the same tension up here, T here. Okay, good. In the string. Okay, so that is T in the string here. So that is tension. Oh, let me bring it up. It's not too obvious where I put it. So we have tension up here. Okay, and then once this mass is heavier, okay, M2 is heavier than M1, okay, then it means that we also have weight M2 here, W2 here. So it means that the system is accelerating where? Down, okay? Acceleration is down. And once this is going down, then it means that this system is also going what? Okay, up. So A here is what? Is positive. Tension will also be positive. Weight, the W1 sine theta is negative. This is negative. This is negative. This is what? Positive. So once we transfer these forces here, okay, we can see that we have tension. Okay, tension which is positive. Okay, then this N, the N here, okay, is in the Y direction. It doesn't account for motion. Okay, neither does W1 cos theta also account for motion. Okay, the only force that is going to be in the X component will be the one we resolve, which is what? W1. Okay, that will be W1 sine. Okay, sine theta. Okay, that will be the only component that will account for motion in the X. Okay, so whilst T is going forward, this is also going to repel the tension, which is negative W1 sine what? Theta. Okay, then what again? We have acceleration here. So this is A, which is positive because it's moving to positive X. Okay. Then on this flip side, I think it's very easy. Straightforward. Tension is positive. This is negative. Okay. And then our acceleration is also downward. So the net force on the system will be what? Negative. Okay. So we can write our equations. Let's take the first equation on the right side. That will be tension, okay, minus M2G, okay, is equals to what? Is equals to negative what? M2A, okay? And the next one will be, for this side, you have the forces, tension, okay, minus W1 sine theta, okay, which is equals to what? This time is positive because A is positive. So we have M1 what? M1A, okay? So this will be the two equations which you'll be using to resolve to find this acceleration and then the